Hello, and thank you for joining me today. I'm at the motion control corner of our studio snack machine. We make stop motion and live action videos here using motion control rigs. And we make most of our rigs in-house. Some of our rigs are designed to be used across different projects. For example, this multi-axis camera slider that I recently finished building is designed to move a camera in 5 different axes: X, Y, Z, pan, and tilt, or it can move an object in different directions. But some other rigs are designed for a specific project according to that project needs. But no matter what these rigs do, they all use the 4 basic components of a motion control system, which I described in my previous video. If you haven't watched it yet, please check it out. They all use an actuator, which in our case is one or several stepper motors. They use stepper motor drivers. They have some sort of controller. And finally, they have some sort of mechanic parts to give us the desired motion at the end of the day. In this video, I will show you what these 4 components look in real life, and I will give more detailed information about each one of them. Let's just start with the stepper motors. Stepper motors look typically something like these few examples that I have here. These motors come in different sizes, and as a rule of thumb, the bigger the motor, they can provide more torque or power. This smaller one provides less torque or somehow power than this bigger one. Let me attach a piece of red tape to the shaft of one of these motors and connect it to a controller that I have here. When we apply the right signal to the stepper motor, the shaft starts spinning exactly according to the number of steps that we want the motor to rotate. Stepper motor is a very cool piece of engineered part. When the shaft rotates from point A to point B, it can hold the position. So if you even apply some force to rotate the shaft more to the left or the right, there is resistance inside and you can't rotate the shaft in the idle mode. Unlike regular motors that when they are in idle mode, there is no power holding the shaft. That's why we can use this for motion control purposes. We can tell these motors where to exactly go and to hold the position in that place. And also that's why these motors consume energy even at the stop point, because they are still applying force to keep the shaft. There are a few basic things that you should know about a stepper motor if you like to start using one. When using a stepper motors, you definitely need to mount it on some sort of fixture or attach it to a rig or something. There are 4 holes on the face panel of each motors that are used for mounting this motor to a rig, so you need the exact dimension of these holes to be able to design a rig, and that's where a standard system called NEMA comes in to make your life easier. NEMA standards are formed by a national association to make sure that all the motors manufactured by different brands has the exact same dimensions. So as long as a motor is compatible with a standard, you can make sure that the dimensions and specifications of that motor matches what you need. For example, these 2 smaller ones are called NEMA 17 standard, which is one of the most motor size standards that are used in tabletop rigging. And these 2 bigger ones are NEMA 23. You can notice that this 2 has different height, but the face panel look exactly the same. So you can easily switch this motor with a bigger one if you think that you need more power without worrying that the whole sizes are matching or not. But as you see, the shaft size are different. It would be so easy to find the right coupling with different sizes. These NEMA series of stepper motors are called bipolar stepper motors. These motors mostly has 4 wires in 4 different colors. Usually the colors are something like this: blue, black, red and green, or sometimes one is yellow, but they are usually in the same family. There are different sort of stepper motors called unipolar, which has 5 wires, like this one, which I believe will not fall in any NEMA category. And it's a smaller motor with much less torque, but I sometimes use a small motor like this for very fine purposes. When you buy a motor from Amazon, sometimes they come with loose wire ends, like this one. And sometimes they come with this 2.54 millimeter female connector, which makes it easier to connect the cable directly to some sort of stepper motor drivers if you want to use those. I think that's enough about the stepper motors for now. And let me go to the drivers and see what they look like and what we need to know about the stepper motor drivers. Drivers come in 2 main forms. Some come in this sort of black enclosure like this two, and some come in this small PCB form. Both of these 2 types has its own uses, but again, as a general belief, the ones in this black enclosure are more reliable to use, but the ones on this small PCBs are more likely to be damaged. These are the devices that take the power from a power supply and also the controlling signals from a controller and convert those signals into kind of pulses that a stepper motor needs to run. As you can see, there are B-, B+, A-, A+ ports here. These 4 are designed to connect the 4 wires of the stepper motor to it, and they have the pins for getting the step and direction signals from a controller and also the power supply attached to this. With these bigger drivers, it's easier to attach the wires to them because of these screw terminals. But with these ones, you need to use something called a CNC shield, or you use a breadboard to put the driver in and then use wires with pin headers to make the connections. When you want to decide on what kind of stepper driver you need, there is a very important concept about drive resolution that you have to keep in mind. For example, in NEMA 17 standard, a full 360 degrees revolution are divided in 200 steps. With such steps, the motor will not move as smooth as we desire for a motion control purpose, because the motor shaft moves step by step, even though those steps are very small, but there are still vibrations and the rotation is not that smooth. So there is a concept called micro-stepping that helps us get a smoother and less vibrant movement. It means that the driver divides each step into multiple steps. For example, in half micro-stepping, each step is divided in 2. So the motor, instead of doing 200 steps per revolution, it does 400 steps per revolution. So the step amounts become smaller and the rotation resolution goes higher. These micro-steppings can be set differently in each of these drivers. For example, in these boxed ones, you can use these small switches called dip switch to configure different micro-steppings. The one that I have here is a very high resolution stepper motor driver. It can divide each step in 128 steps. But for example, this small PC ones, the red one, which is a very common driver called A4988, can divide each step in 16th microstep, and this one can divide each step in 32. There is another very important parameter in choosing a stepper motor driver, and that's the voltage and the current that are used by the stepper motor. Common voltages that are used for stepper motors are 12, 24, 36, and 48. I myself use 12 volts in some applications and use 24 volts for some other applications. Also, you need to make sure that your stepper motor driver can handle the current that your motor needs. This size NEMA 17 stepper motors usually can drain up to 2 amps, but 1.5 amps is a good steady current for this kind of stepper motors. But this smaller stepper motor cannot handle more than 1 amp. This big one can handle up to 4 amps of current, which needs a powerful driver and a power supply to be able to provide that voltage and current to that. So you need to make sure that the driver that you choose can handle the voltage and the current that your motor needs. If you remember from my previous video, the controller is like the brain of our system. It's the controller that tells the driver what to do, and then the driver tells the motor what to do. For the controller, we can both use a computer or a small integrated computer called a microcontroller. For example, this board is called an Arduino. It has a processor and some input outputs to be able to program it to work like a small computer integrated in your system. But I'm not using the computer as a controller for any reason. I use Arduino boards a lot. The reason I started using Arduino is that DragonFrame supports Arduino as an interface with the drivers. So I started using Arduino with DragonFrame, and gradually I started programming Arduino for different uses as well. So sometimes I make my own controlling devices. Sometimes I use Arduino and DragonFrame as a controller. If I use a computer as a controller, my software would be the DragonFrame because it's suitable both for stop motion and live action. And since we shoot both stop motion and live action in our studio, I use a DragonFrame DMC32 as a controller. For using an Arduino as the controller component of our motion control system, we write a program compatible with Arduino on the computer, and we load it on this board. So this board works like a computer which has a program inside. Then we connect the appropriate pins of the Arduino to our driver, and also we connect the power supply to the driver as well, and then we connect the driver to the stepper motor, so the controller sends signals to the driver and the driver sends the electric pulses to the stepper motor, so this can work together. For example, these are the controllers that I've built previously for when I don't want to use DragonFrame. As you can see, there is an Arduino Nano, a smaller version of this Arduino board here, which I programmed it to take commands with this push buttons. And there is one stepper motor driver here, which is connected to this port. So you can connect the stepper motor here and kind of set the start, stop, some speed and some parameters for the stepper motor and make it run without using a computer. And this one is a more advanced version of this controller. I've put an LCD on this one for easier controlling. And as you see, there is also an Arduino inside this box, which I programmed to be able to communicate with these buttons and the LCD and everything. But in this one, the Arduino is connected to this DB37 port, which can be connected to a separate driver box that I will show you in a minute. So there are no drivers inside this controller. This is a driver box that I've built to work with DMC32. It has 8 drivers for 8 stepper motors, and each driver has its own on-off switch, so I can turn off the motors that I'm not using. There is a door on the top, so I can access the drivers to set the current of each stepper motor in case I connect different stepper motors to the drivers for different purposes. And also if I want to change the resolution of the drivers according to what rig I've attached to. And here is the DMC32 that we've got from the DragonFrame. They make this awesome interface hardware that can move up to 32 stepper motors synchronized, and it has great compatibility with their own software, DragonFrame. So this is what we use for both live action and stop motion. And finally, we get to the mechanics part of the system. With all the controller and stepper motor drivers and power supply and the motor, what you get is a rotating shaft. With a rotating shaft, you cannot do much. We need some sort of mechanics attached to the motor shaft to be able to get the desired motion. The mechanics can be as simple as a circle piece of wood with a coupler to attach to the motor shaft, so you can place something on top of it and make a small turntable, or it can be something more complicated. And it is where your creativity comes in. In the electronics part, it's more about making a reliable setup. And you don't need to be as much creative in that because it's something that needs to be done exactly according to the data sheet of the driver or the stepper motor. So you know that you have all your connections right and your motor is rotating, and you can send commands to it and it will rotate exactly the way that you want. But for the mechanics, it really depends on the project that you're working at. And you can use different materials, you can use different methods of making, and that's the real DIY part of using motion control in stop motion and video. And that's actually the most amazing part of it. I like designing different rigs for different purposes. And in my design process, I use 3D printing, CNC cutting, laser cutting, woodworking. I use wood, aluminum. I sometimes use hand tools and sometimes use power tools. So there is no limitations. Let me just show you a few examples here so you get the idea of what the mechanics could be. For example, for a project that we needed to put a phone inside a microwave and shoot like we are shooting from the point of view of the food spinning inside the microwave, I created this rig. I designed it in Fusion 360 and 3D printed the parts. And as you see, these gears are attached to the motor. This small gear rotates this bigger one, and the base is 3D printed as well. And there is a phone mounted on top of this, and program and move where the phone starts rotating and when it stops. So this is an example of how you need to make something to get the movement that you want. This is another example of a rig that can transform the rotational movement to linear movement. You see how I can change the angle of this plate by rotating the motor back and forth. And this rack and pinion gear can push the plate up and down and change the angle. Probably one of the first things that people like to build when they think about using motion control in their production is a tilt pan head for the camera and a slider. And this is one of the first things that I built. This is a DIY tilt pan head. And as you can see, it can pan and tilt up and down. It runs slow with this controller because of the geared stepper motor, but with Dragon Frame, it runs much faster. So this is another example of building some sort of mechanics to be able to get the motion that you need from your motion control system. I hope this video had some useful information for you if you're willing to enter the world of making DIY motion control systems for stop motion, video making, and if you like to make your own motion control rigs and enjoy watching some electronic and mechanical parts work perfectly together and give you the smoothest movement according to what you program. Please let me know if you have any questions about what I talked about, what topics you'd like to learn more about, and please don't forget to like this video, subscribe to the channel, leave comments, and thank you for watching. See you next time.